afternoon, everyone. So, my name is Adrian Buckley. I work for Siemens, and I'm responsible in Siemens for the electronic design automation business in Europe. And I must say, it's a pleasure to be able to come here today. This is my first time in Armenia. It is well overdue. I will come back again. I'm already impressed, and what a fantastic venue it is also. Thank you. So I'm going to talk about semiconductors. But just before I do that, I wanted to talk about a friend of mine that I met earlier this year. And this friend of mine had retired. And I was chatting to him about how his retirement had gone. And he told me that he'd put together a very sophisticated spreadsheet so that he could work out how all of his investments would work, how his tax would work, all of these things. Now, I've seen these types of spreadsheets before, but there was something that he did which impressed me, because in his personal plan, he built in world recessions. He assumed that about every 7 to 10 years, there would be some form of financial dip within the world economy. So I was pretty impressed with that. Some of you here, some of you may be old enough to remember the dot-com bubble burst in 2000. Economists describe that as a U-shaped recession. That's because it goes down fairly sharp, it stays down, then it comes back up again. In 2008, 2009, there was the subprime mortgage problem where the financial world dipped. It was a V-shaped, very sharp down, very sharp up. The next one is a U-shaped one, and that was caused by COVID. There's another recession that's been affected, and that's caused by the sanctions that have been happening and also supply chain problems. I showed this slide about 6 months ago, and on the slide, it was showing that we were dipping into a world recession. But at the time, we looked at the fundamentals in the semiconductor market. This is semiconductor effect from worldwide recessions. And we concluded that it would be short, a very, very short V-shaped depression. And the reason we did that is what this talk is all about. The reason that the semiconductor market has now bounced back so quickly and is now also expected to grow very strongly is because of the fundamentals inside semiconductor. I'm going to talk about the role of semiconductors in a very changing world. There's been many events which have had a fairly radical effect on semiconductor, but it's also elevated the role of semiconductors. In 2020, we had COVID. COVID did a couple of things. One of them is it exposed supply chain weaknesses, but it also showed us how we could move to a virtual world. I know in the past there used to be teleconferencing systems, but they never seemed to work. Everybody still flew all over the world. But now with Teams and Zoom and things like that, which are all powered on silicon, a virtual world became possible. The second piece is to do with the new area of trade and trade disputes and wars, particularly between the US and China. And this has caused, there was some comment about it a little earlier, it's taken a global semiconductor market and it's sub-optimized it into different regions of the world. That also has an effect, which I'll touch on semiconductor. And third, AI has been mentioned several times today, and we really are at the foothills of AI, but that will have a profound effect on the way that we use electronics and silicon in the future. Finally, the youth of today have grown up in a world where a green world is important. And for the younger people, maybe here today, it's very important that we have a sustainable future. So this also has an effect. The combination of these effects and many others has elevated the role and the demand for semiconductors all around the world. Somebody once said that software is eating the world. I'm not exactly sure what that means, but I know that hardware is feeding the world because that software sits on silicon and data is driving it. We had a conversation a little earlier about smart countries and smart cities. The amount of data that is being collected, transmitted, and processed in our cities today is astronomical, but again, is only at the very foothills of what's about to come. But there is a problem. There's always a problem. There is a dilemma. And the dilemma is just at the point where the demand for semiconductor is so high and the complexity of semiconductor, again driven largely by AI, is increasing and increasing. Just at that time, around the world, there is a massive shortage of university graduates that can do hardware, that can design silicon. And also, there's a whole group of people like me who have been in the industry for 30 or 40 years, and they're getting a little old, and some are beginning to retire. So there is an increasing shortage in the number of engineers all over the world just as semiconductor explodes. And that leads to a whole series of challenges which have to be addressed, some of which I'll touch on. This chart here shows the 6 vertical markets within the semiconductor industry. So you can see at the bottom, the biggest is computing and data storage, wireless, automotive, industrial, consumer, and wired. There is something that is happening at the moment which is unprecedented, and that is every one of those 6 segments are all growing simultaneously. They're all growing at the same size. On average, they're growing at about 7% year on year on year. And that means the semiconductor market will become a $1 trillion market by 2030. I'm not talking about the electronics market, I'm only talking about semiconductor. In the 1970s, if you went out and bought a piece of electronics equipment, although there wasn't that much around at the time, about 8% of the revenue generated by that piece of electronics was accounted for by the semiconductor, by the silicon that was in it. Jump forward a couple of decades, and that's doubled to 16%. Come forward another decade, and now it's at 25%, going on to 26%. And the electronics market has become, and will shortly become, a $3.4 trillion business. So for all of you here that are in electronics, I would like to say to you all, well done, because I think you're in the right segment. This is a good place to be, and I'm going to show you a whole load of numbers that excite me and I think reinforce that position. In 2012, the big companies like Google and Meta and Tesla and Google and Facebook, and Bosch, etc., very, very few of them created semiconductors. They mostly outsourced to other companies to do that. But if you roll the clock forward to 2022, so last year, it's gone from 2% of the revenue came from those big companies, but now 23% does. But not only that, the CAGR, the compound annual growth rate over 5 years, as you can see on the chart, is 30%. That's a massively growing area. And if you think of those companies, they're the richest companies often on the planet. They can move armies in order to be able to make this succeed. So unsurprisingly, the number of ASIC design starts that make it to a foundry has also been growing year on year. If you look back to 2002, it's growing at about 5% a year, but relentlessly, year on year on year. This chart looks a little bit like the first chart I showed you. But the first chart was all about revenue, and revenue is a lagging indicator of what's happening within the market. Research and development and investment is a forward-looking indicator. So you can use this to decide perhaps what's going to happen next. And the reason is simple. The R&D money that goes in today creates the products that come out typically in 2 or 3 years' time. So it's a really good indicator. And you can see since 1982, which happens to be when I got into electronics, there's been a steady growth despite some periodic feedback and pushbacks because of the economy changes. But the most interesting thing about this chart is that for the last 7 years, there's been no downturn in research and development input from companies around the world, despite the fact that we've had the sanctions, the IC shortages, we've had COVID, they're still investing. To try and understand this a little bit better, earlier this year, KPMG and GSA did a survey. They went and talked to the top 100 semiconductor executives around the world, and they asked them, what is your sentiment about capital spending, global workforce, and R&D spending? And you can see on R&D spending, only 8% of those companies said that they would reduce their R&D. So 92% will either keep it the same or the majority will actually grow it. So can you imagine if you are one of those executives and everybody around you is increasing their R&D investments, looking forward to the upturn, and you make the decision to reduce your R&D spend? You only do that when you absolutely have no other choice. So this is a strong indication as to what's going to happen next in the industry. So a lot of the stuff I talked to you about there was more economics, revenue and R&D spend and things like that. Let's for a moment just touch into some of the applications that is driving the electronics market. So the first one is automotive. It would be no surprise to you that more and more electronics is appearing within your cars. But there's something else going on, despite the fact it's growing at 11%. And that is that the complexity of those semiconductors is also increasing. It used to be that all of the electronics in your cars were on fairly modest nodes, fairly mature technologies. But as you think about autonomous driving and some of the infotainment systems that are in your cars, these are now leading edge system on chips at 5 nanometers, at the bleeding edge of technology. So automotive is a huge driver of the semiconductor industry. I like this chart here. Sometimes, not me obviously, people exaggerate and they say we are in an exponential growth area. Well, when it comes to the amount of data traffic that is being transported around the world today, all of which runs on silicon, we are truly in exponential growth. And as you can see in 2023, we've already been experiencing it, but we're not even in the foothills. Look how much data is going to get generated. In 2030, there will be 1 trillion IoT, Internet of Things devices, baked into our cities, into our roads, into our bridges. There's going to be a massive explosion. And you can see things like gaming and video, but look at these CAGRs. This is growth at the side here. So automotive, 139%. Wearables, 122%. This is extraordinary levels of growth. And again, you're definitely in the right industry if you're in electronics. All of that data needs to get transmitted, and 5G, without any doubt, has come of age and is deploying and has been deployed all around the world. But one indicator of this is if you think about your mobile phone, if you compare a mobile phone that had 4G in it, and now you have one with 5G in, there's 40% more semiconductor revenue and content in the 5G phone. About 75% of all of the revenue associated with mobile phones in the future will be to do with its connectivity, with its 5G and other connectivity methods. This data that gets collected and then it gets transmitted ends up somewhere, and it ends up in data centers. Data centers are the biggest consumer of silicon. And so again, it's not a surprise to find out that it's growing pretty well. It's growing at about 11% year on year on year at the moment. But that is expected to grow to around 14%. And also, as AI makes a bigger play, you'll see that grow again and again. There are companies all over the world, startups and established companies, that are re-architecting what a central processing unit, a CPU, looks like. And the reason that they're doing that is because they're making architectures which are specifically designed to run AI applications. This is a revolution in the semiconductor market, happening alongside all of the other trends that I mentioned to you a little bit earlier on. So the compound growth over 10 years is anticipated to be around about 32%. That's 32% year on year on year that industry is going to be growing. This was discussed a little earlier. The semiconductor market used to be truly global, but it is suboptimizing into the major regions of the world. Many regions and continents of the world have released their own Chip Act. So you can see on here, Japan has dedicated 6.8 billion. If you look at North America, 52 billion. If you look at Europe, a little bit closer to home here, 47 billion. So maybe this isn't such good news in terms of the collaboration of technology around the world. Maybe it's not good news. But it is also replicating and driving silicon as each of the regions of the world decide to design their own. So this will have a profound effect on the amount of activity that happens around the world in the future. It will affect pretty well every business, from aerospace to medical, from consumer to industrial, and a lot of it will come together in smart cities where that collection and transmission and storage of data happens. So this affects pretty well every aspect of our public lives and actually our virtual lives also. So I work for Siemens. So what's Siemens doing about all of this? Unfortunately, there's no magic wand to fix everything. But what we are trying to do is to build technology that takes into account the effects that I've talked about. So the vision within Siemens, which we're gradually delivering on, is to be able to take a system from a single transistor all of the way through to a fully bound system, where a system is not just a CPU and some memory, it's an autonomous car driving down a virtual road and everything in between. But it takes into account that you need to be able to do this with less resources because of that dilemma I described a little bit earlier on. Also, quality has to improve. You cannot spend the amount of money you need to spend now on building a full, sophisticated electronic system and find out that it doesn't work when you actually build it. And also, we've got to simplify technology access for companies all around the world. So there are three main pillars into which Siemens is putting its R&D money. The first one is called process technology scaling. Then there's design scaling and system scaling. So just to kind of decode this a little bit, what process technology scaling means is how do you take the same piece of silicon that you had 2 years ago and now put twice the amount of transistors on it? The second piece, design scaling, is how do you put, over a period of 2 years, twice the functionality that you had before, but with the same or less engineers? And then the third thing is system scaling. How do you take huge software stacks and sophisticated semiconductors, and how do you get all of that working in the context of the system that it'll operate on, whether it's making mobile phones and you're simulating an entire mobile phone system from handset through to the base stations through to the back, or autonomous cars, the example I already gave. Now, in order to do this, it's not enough to just build your tools a little bit better, make your simulators run 2 or 3 times faster than they did before. That isn't going to cut it. And that's why AI has a pretty profound effect in this market, just like many others. With the use of AI, it becomes possible to left shift decisions about electronic systems and semiconductors and make really intelligent, informed decisions at the front end of the design process. Also, it allows you to put orders of magnitude improvement into the tools that your customers use. Not 2 or 3x, orders of magnitude. The explosion of data that comes from this also has to be tamed, and that's a great way and a great application for AI. And finally, there are deep insights that need to be extracted from this data. Insights that a human theoretically could do, but it would take so long, it would be irrelevant to the product life cycle of that particular product. So AI has a big effect on this as well. It is a race to get the technology out there in order to be able to make this happen. On the upper half of this slide, these are some of the R&D investments we've put into tools that already exist. We're augmenting them, we're adding AI to them, we're making them better. But that isn't enough to be able to keep up with the demand. On the lower half of this slide, these are companies that over the last 3 or 4 years, Siemens has been acquiring to augment the technology that we're developing. You know, for example, there's a company here called 𝐒𝐢𝐞𝐬𝐞𝐬 𝐄𝐃𝐄ℎ is an AI tool. It was built with AI in mind on day one in around about 2010. It's now easily become the market leader because it runs orders of magnitude faster than anything else Siemens or anybody else has got. If you look at this piece here, supply frame, I mentioned briefly earlier on about the supply chain problems that affected world recessions. Supply frame is designed to try and avoid that situation in the future as it regards to electronics design. I'm going to give you 2 quick examples about what does all this mean. I did mention when I was on the panel a little earlier that one of the biggest challenges in electronics today is how do you get the power down? You know, we want a green planet, but also we want our mobile devices to be able to last on their batteries as long as we possibly can. And so getting power down in electronics has become an obsession for pretty well all of the applications, certainly all of the mobile ones. And so by taking a holistic approach and integrating together a whole suite of tools from lots of different perspectives, it's possible to be able to design a new piece of electronics where at all points within the design process, you know where you are from a power budget point of view. So right at the beginning, you can run billions of cycles of simulation to figure out what does the power envelope look like on my device? Will it be able to last long enough when it goes into a mobile phone? And as you move through this progression, you start to get more and more detailed in the design. And okay, billions of cycles become millions and eventually become hundreds of cycles. But there's no surprise at the end because you built power in at the beginning and you optimize for power all of the way through. This example is to do with system. And this is about autonomous cars. So it is completely possible today, in fact it is happening, to build a virtual car in a virtual city and then go and figure out how it's going to operate. It's even possible, and maybe even more importantly, to build a virtual production line. So you can take a virtual car, put it through a virtual production line, and drive it on a virtual city to figure out whether it's going to be safe, is it going to work, is it going to have the right power budgets, everything else. In order to do that, you need to orchestrate together a whole load of technologies in order to make it humanly possible to do such designs. There are companies today, you may know some of them, you may be one of them, that are building their factories and their production lines and their products completely virtually. And it's much later in the cycle before the first brick gets put in place. And the basis of all of that, certainly in this example, is the silicon upon which it all sits. I've got a friendly proposal, and I realize that this is my first time in Armenia, so I apologize if I've misunderstood what's going on here, but I'm really interested in what's going on in Armenia. And the reason for that is I get the sense that the government has an appetite for developing this type of economy. And that's a really big, important piece of the jigsaw puzzle. The second thing is, I've learned a little bit about your universities, and I can see that that vital resource of well-trained engineers and software engineers has something that could happen here. So I'd like to make a gentle, respectful proposal. I'd like to make a proposal that you put together a national chip design center. And in that center, it's holistic. It connects together, and I know you're already doing this in various application areas. It's taking the universities and the engineers that exist today and the technologies, and it's binding it together with a unified, centralized management. And then use that center as a national champion to blend together cutting-edge technologies in the design space, together with the global ambition that perhaps exists here. And maybe this center could serve, firstly, the local economy that you have here, but also serve the broader economies. For example, Europe. Europe is very nearby, and as I told you, the CHIPS Act, $47 billion has just gone in there, and there isn't enough engineers. Who's going to do all the work? I think this would be a great opportunity to be able to not only serve the local market here, but also maybe serve further into the international market. Again, I apologize if I'm offending anyone because I'm ignorant, because it's my first time here, but I would get really excited about that, and I would want Siemens to help make that happen in different ways. So if it's something that you're interested in, it'd be great to discuss it. Good. Okay, so let me just do a quick summary to finish. So to start with, I talked about these convergent megatrends. All of these things that are driving the semiconductor market all together simultaneously, and we're only at the foothills of technologies like AI. It is an incredibly bright future. I'm an optimist, and I'm also told that I get a little bit too carried away by things. But honestly, I cannot work out how this is not going to be an extraordinary development within the semiconductor market in the future. I talked a little bit about what Siemens is doing about it, trying to enable that level of design when there's a shortage of engineers and an explosion in complexity. And then finally, I mentioned a little bit about the money that is going into the semiconductor market around the world. So again, the semiconductor market will be a $1 trillion market in just a few short years. The electronics market shortly will be a $3.4 trillion market. And I showed you compound annual growth rates in the 30s and even in the hundreds. So I think it's a really bright future. Thank you very much for your time.
Շնորհակալություն. Some questions. Հարցեր, մի քանի հարց։ Համեցեք։ Հետո այստեղ խնդրեմ։
Hello, thank you very much for the, here on the left, for this interesting presentation. I have a question. So last year, US has approved this CHIP Act, after which now the United States is willing to regain its competitiveness, yeah, in the semiconductors manufacturing. So what do you think, what will be the role of countries like Armenia or other small countries which are positioning themselves in the tech industry, and they want to be in the map of the world? And what will happen with the small countries like Armenia after these big ones will start to compete with each other? Thank you very much.
Thank you for the question. So I think we all heard the question there. With the CHIPS Act in America, you know, what would be the role of Armenia? Well, it's true, you know, the motivation for these CHIP Acts is to be able to build more resilient design chains, so that if there's a chip shortage around the world, it doesn't drastically impact the economy. But it will never get to the point where true sovereignty has been achieved, where an individual country is completely self-sufficient. And the reason for that is because, as I mentioned earlier, the semiconductor market is already global. It is designed to be global. All of the technologies in it are global. Collective learning is global. So it will never, in my opinion, get to the point where it'll be total self-sufficiency, although some regions of the world are attempting to do that. But there is that counterpoint problem, and that it's great to have the ambition to be self-sufficient, but if you just don't have the wherewithal to do it because you don't have enough engineers, it's a pipe dream. So I think companies like Armenia and others could certainly have a role to play in being able to augment that situation. Probably the biggest motivation, perhaps, is to do with taking well-educated engineers and being able to get them to deliver solutions into these markets around the world, not just Europe, but beyond Europe. Does that answer your question? Thank you.
Շնորհակալություն, համեցեք։
As you may know, SoftBank is going to invest $1 billion into Jony Ives, Apple's former chief designer's idea of iPhone of artificial intelligence. So when the AI will be in processing level in iPhone. So what's your opinion about that, about AI in a pocket? For some guys, it will be scary somewhat. And this is my second question about what is your viewpoint about the neuromorphically designed AI chips when biological components, tissues, for example, are meshed with silicons in semiconductors. Thank you.
Thanks for your questions. So let me take the first question first. And the reason for that is I don't know enough to give you an answer on the second question. But let me take the first question first. So what about having AI in your pocket? There are definitely concerns about AI. I read a lot about Elon Musk, and I've read all of the things he's written about. We should be worried about AI. However, I think it is inevitable. It's kind of evolution. And I am, by nature, an optimist. I think it's coming. I think it's already coming. And I think the economics will drive it further and further. But the optimist in me believes that what it's allowing us to do is to come up levels of abstraction and the way that we work and the way that we design and the way that we do things. So ultimately, it does have the power to be a positive influence. But I do keep thinking, but what happens if, and it goes wrong. But, everything will, it's already set. Everything's going to have AI within it. And I think very, very soon. So I think it's an inevitability. And I think there were some discussions earlier about what can we do about legislation and control and privacy and things like that. I don't know what the answer is, but I know we've got to do it now because it's happening now. If we don't do it now, it won't be built in and it'll be too late. But, so apologies, I can't answer your second part of your question. Yeah, I don't know enough to answer that in a good way.
Եվ վերջին մեկ հարցը։
I want to know, have your company any plans to cooperate with Armenian universities? For example, Yerevan State University or other universities?
Thank you. So have we got any plans to cooperate with universities? The reason that I'm here, admittedly for the first time, and apologies for that, is because we are interested. And we're interested for the reasons I gave during my talk. Because when you've got universities with a good reputation and a good number of engineers within it, we want to know about that. What the scarcest resource are the people who have got the capabilities to be able to do this type of design. It's a frighteningly small number, even on a global scale. So yes, we do have an interest in doing that.
Thank you.
Thank you very much, Mr. Buckley.
Thank you.